Hi everyone, it's Mr. Baker here. Today we're going to be looking at potential difference in this physics video. Okay, so we're going to be looking at potential difference today, and we're going to be answering this question: what's the voltage of a lightning bolt? So you don't know how proud I am of this animation. This took me a long time. So let's have a look at the explanation of potential difference. So what have we got here? We have just seen in the last lesson that electric current is the flow of charge in a certain amount of time. So I've got all of these charges that are being pushed around the circuit by this power source, and you can see these circles are being pushed around my series circuit here, and so they've got a flow. There's a flow of charge in a certain amount of time. That's the electric current, and you can also see that as they go through that cell, they go from being something that says 0J to 1J. That J there stands for joules, so they have 0 joules and then they have 1 joule. So they've got no energy and then they've got some energy as they go through the power supply. And then as they go through the wire, they don't lose any of that energy. But as they go through the lamp, you can see that they go from 1 joule to no joules. But the lamp is lighting up. So they're giving their energy to that lamp and they're transferring that energy electrically so that then the lamp can radiate some energy as light. And it's that difference in energy per charge that is what potential difference is. So if you think about the words potential, the potential to do something, it's like energy, potential energy, and it's the difference. So we're really looking at the energy difference per charge, and that's what voltage and potential difference are. So current moves from positive to negative. The potential difference across the power supply tells us how much energy is transferred to each coulomb of charge. Each charge then transfers this much energy to the components in the circuit. So potential difference, the definition, is the change in energy per charge. A charge gains energy when it goes through a power source and loses energy when it goes through a component in the circuit. So we can write this down like this. We can say that the energy transferred equals the potential difference times the charge. And we've got E for energy transferred, V for potential difference, because potential difference is measured in volts. You could also say voltage instead of potential difference. And charge is Q for the quantity of charge. So E equals V times Q is our equation, where V is the potential difference measured in volts, E is the energy transferred and measured in joules, and Q is the charge measured in coulombs. Again, really important equation, this one. So like electric current, the definition of electric current being the rate of flow of charge being absolutely fundamental to your understanding of electricity, knowing what potential difference is again really important, and having a really good understanding of what this is going to really help you in future lessons about electricity. Okay, so let's have a look at a little example. So the energy transferred to a bulb is 360 joules when 64 coulombs of charge passes through it. Calculate the potential difference across the bulb. Okay, so whenever you're doing a question to do with equations, always remember DESRA. What do I mean by DESRA? Well, D for data, first of all. And here our data, we know that the energy is 360 joules and we know that the charge is 64 coulombs. E, equation. So our equation here, we know that the energy transferred is the potential difference times the charge. So our energy is E, our potential difference is V, and our charge is Q. So E equals VQ. S, substitute. So substitute in your values. We know that the energy is 360, so we put that in. Then we don't know what V is, that's what we're finding out. And we know that the charge is 64, so we put that in. Now, R, rearrange it. You need to be able to rearrange that equation to get V equals 360 divided by 64. And then the last one, answer. The answer here is 50, and it's 50 volts. It's potential difference, we're measuring it in volts. If you try and do it in that order, whenever you've got an equation question, then you will pick up marks. Okay, so that's the end of this lesson on potential difference. These are the things you should be able to do. You should be able to define the term potential difference and describe what a power source in a circuit does. And you should be able to rearrange the equation for potential difference and apply it in different situations, which you'll need to do a little bit of practice on. But once you've done some practice, I'm sure you will be flying on it. Okay, so we asked this question at the beginning then. What is the voltage of a lightning bolt? Okay, so what was your guess? What's the voltage in a lightning bolt? Did you guess 1 billion volts? Okay, so a typical lightning bolt might be about 1 billion volts. A battery at home might be about 3 volts. A plug in your house, a plug socket, might be about, well, it's 230 volts. So a lightning bolt will supply 30,000 amps for about 0.5 milliseconds, and it will deliver about 15 coulombs. How much energy does it supply then? So if the energy transferred from today's lesson is the charge times the potential difference, then the energy is 15 times 1 billion. That means 15 billion joules. So the energy transferred in that small amount of time by a lightning bolt would be 15 billion joules. If you compare this to the same amount of charge coming out of a plug socket would deliver about 3,450 joules. So there you go. Okay, so that's been another physics video all about potential difference. I've been Mr. Baker, and I'll see you next time. Thanks very much.